guys, this is Mr. Felton. This video is going to go over solving rational equations. An example of a question we'll be solving later on in this video is one right here. So just kind of give you an idea of what we'll be solving. Okay, so let's get started. So let's start off with something a little bit more basic. How would we solve a rational equation like this? Well, it says right here, rational equations can be solved by eliminating the denominator. This can be accomplished by multiplying both sides of the equation by the least common multiple in the denominators. Okay, so least common multiple in the denominators. Let's go ahead and figure that out. So what's the least common multiple of 3, 4, 12? And so we know that 3 goes into 12, 4 multiplies into 12, and 12 multiplies into itself. So our LCM is going to equal 12. And so we're going to multiply both sides of our rational equation by 12. And that's going to look like this. X over 3 plus 3 over 4 equals 12 times 5x over 12. All right, let's multiply it in. And right away, one of the things you guys should see is these 12s cancel out. And so when we multiply the 12 through, we're going to get 4x plus 9 is equal to 5x. And after we work out some algebra, we're going to end up getting x is equal to 9. Cool. All right. So let's move on. All right. So what are the steps to solving rational equations? So for the one that we're looking at the beginning, this one right here, we are going to need to follow these steps and make sure we don't solve it incorrectly. All right, so what's step number 1? All right, we got to make sure we factor everything. This includes everything in all the numerators and the denominators. It's very important. Step 2, determine what the domain is. So that's where we look at a denominators, find out where x makes the denominator equal 0, and say that doesn't exist in our domain. Step 3, determine the least common multiple in the denominators. That's kind of like what we worked on in the last slide. We're going to multiply both sides of the equation by the LCM, solve the equation for x, and check for any extraneous solutions. So when we're working with quadratics in these rational equations, we got to make sure that everything or all x's work out in our rational equation. Okay, so let's go ahead and solve this one. All right, so first step, factor. Got to make sure we factor everything completely. And it looks like the only thing in this problem that we need to factor is this x squared plus x minus 2. And so we can just rewrite this. Say 3 over x. Here, I'm going to run out of room right now, so let's move it over here. So let's do 3 over x plus 2 plus 3 over x minus 1 is equal to 5x. And once you factor that denominator all the way, you're going to get x minus 1, x plus 2. All right, cool. So we factored completely. Now let's determine the domain. Okay, so here in our domain, x cannot equal 2, x cannot equal 1. I'm sorry, x cannot equal negative 2 there. Sorry about that. And it's the same thing for this one right here. We're going to get the both negative 1 and, or negative 2 and 1. So x cannot equal negative 2 and 1. And this is going to be our domain right here. And of course, x is going to exist for all reals. Okay, so now we found our domain. Let's go ahead and find our least common multiple. And so we know that x plus 2 is a multiple of x minus 1 times x plus 2. And x minus 1 is also a multiple of x minus 1 times x plus 2. So perfect. It looks like x plus 1, or x minus 1 times x plus 2 is going to be our LCM. All right, so we're going to multiply both sides of our equation by our LCM. And so that's this step right here. All right, so we're going to have x plus 1. I keep saying that. I mean x minus 1 times x plus 2. And I'll multiply that all by 3 over x plus 2 plus 3 over x minus 1. And that's going to equal to, and of course we multiply our LCM on both sides. Okay. Cool. So right away, we can cross out these guys right here. And so when we multiply out, we're going to get, or when we multiply this x minus 1, x plus 2 into our blue stuff, we're going to get 3 times x plus 2 plus 3 times x minus 1 is equal to 5x. Okay, and so now we have to distribute these 3's over, and I'm going to pause the video and come up with a solution here in a second. Alright, so after doing some algebra, multiplying or distributing that 3 into both the bubbles, we end up getting that x is equal to -3. Alright, so let's move on to our final example in this video. Also, this video isn't enough practice for you guys. There will be another video that provides additional examples. Okay, so let's do this one. Alright, first step, factor. Boom. Okay, so we can't factor anything on this side, on the left side, but it looks like we can factor with this guy. So let's go ahead and do that. So this is going to end up being 3 over 3x minus 1 is equal to 2 over, I'm going to go ahead and pause the video. I know you guys know how to factor, but I'm going to pause it to save us some time. Alright, so after factoring, we should get 3x minus 1 times x plus 2. Okay. Cool. We factored. Now we figure out a domain. So here we can see that x does not equal 1/3, and it also doesn't equal -2. But it does exist for all the other real numbers. Okay, so we figured out what our domain is. All right, 3. LCM, what is the least common multiple of our denominators? Well, here we can clearly see that 3 multiplies by something to get into 3x minus 1 times x plus 2. And we know that all this is a multiple of itself, so perfect. Our LCM is going to be equal to this whole entire denominator right here. All right, so what we've got left to do is multiply by the LCM on both sides of our rational equation. So we have 3x minus 1 times x plus 2, all that, times 3 over 3x minus 1. And that's going to be equal to 3x minus 1 times x plus 2, all that multiplied by 2 all over 3x minus 1 and x plus 2. All right, cool. So now we just have to multiply in, and right away we can see that these cancel out, and that these are going to cancel out over here. Okay, so now what we have to do is distribute this x plus 2 over to the 3, and so we're going to get 3 times x plus 2 is equal to 2. And so from there, we're going to get x is equal to negative 4 over 3. The way that I got that is I just distributed this 3 over and then got x by itself and solved for it. So one thing I'd like to state that I haven't been doing in this video is how I haven't been checking for to see if x is the correct solution. And one thing you should be doing is plugging this x back into here to make sure that both sides of the equation equal each other when you substitute x in. And so here when I substituted x in, I ended up getting 0.25 on both sides. And so by getting 0.25 on both sides of this equation, that showed me that it worked out because they equal each other. All right, cool. So thank you guys for watching. Again, if this was not enough practice for you guys, there will be another video that'll provide you guys with more examples. So yeah, please watch that if you need that. Thank you.